into tutorial or however you want to like. It's not like a tutorial because I'm not a professional C++ developer. I don't know how to write a framework of C++ or something like that. But I want to discuss some best practices that hopefully will be useful for you even besides beyond C++. So if you ever decide to work on like PHP or some other language, you probably would be able to use it. So first of all, like if you haven't already, please join that either on your laptop or on your phone. So does it work? No. I will join it. So we will be working with some code that I've written, and also we'll discuss. We'll have some handout assignments with paper and stuff. Especially if the internet on my laptop will decide to connect kindly. So generally, the topic of this is smart pointers. So let's do a little bit of a pretest. What people know about smart pointers? Okay. Yeah.
They use something automatically for you?
Yes, that's why they're smart. You know, they're like smartphones and regular phones. They have smart screen, and you can work with them. So the idea is that smart pointers is a way of dealing with memory management in C++. So how do we traditionally deal with memory management in C++? So what's memory management? That's the first question.
The C++ does it for you.
How
most
exactly?
of the time.
Yeah, so what's memory management? When we say memory management, does it mean that, like, I don't know, you open the photo album and look at our childhood photos, and I'm like, oh, such a nice memory. Now let's do that in C++. What's memory management?
Tracking how much you use and how much you should.
So when we create an array or an object or something that bigger than like 4 bytes, we need to store it in operative memory. So in Java, that happens automatically when you write new keyword. The object or the array or whatever is created on in the memory, and then it automatically gets garbage collected. So what's garbage collection?
So basically,
Sure.
Basically deleting all the user memory that you don't use anymore, like in the next time.
So yes, that's how it works. What is it like? Is it a program? Is it part of your program? Is it something else? So when we say garbage collected our garbage, does it mean that there's small, I don't know, little people inside our computers that take garbage and throw it away? No, right? So what is it then? It's a program that runs alongside of our program. If you remember the structure of Java, we have Java runtime environment. So that means that when we try to run Java program, actually a lot of stuff going on, including the additional program which is garbage collection. But garbage collection is slow, right? So that's why creators of C and C++ didn't use any garbage collection. What do they rely on, especially in C?
on developer.
On developer. So on developer, do not forgetting to press to delete the memory themselves. So how do we do that in C? Those who have taken a class in C, which I assume is everyone.
How do you free them?
Yes.
Clear.
No, it's not clear.
Free.
Right? So you do malloc, which allocates memory allocation, malloc. And then after you don't need that memory, you do free. So what about C++? Do you need to use malloc or free? No, right? What do you use instead? Distractors. What's a distractor?
Well, if you reach this the scope of the function that the object is in, the distraction is called and it destroys
Destroys the object. What about arrays? So imagine that we have good old a C array, not a vector, anything, right? Can be created in C++? We can, right? So we created. Who will delete it? It will be deleted by destructor.
No, you have to do it.
No, you have to delete it yourself. Do you need to use word free?
No.
Not necessarily. So that brings us to the idea that in Java, all objects and all arrays are created on the heap, right? So we differentiate between two memories, heap and stack. Stack is faster, heap is slower. Both of them are data structures, by the way. We already discussed how stack works. Maybe we will discuss how heap works with my sophomores. But generally, and small things like variables, integers, charts, and stuff like that is allocated on the heap in Java, and everything else, arrays, objects, are allocated on the heap, right? In C++, it works a little bit different. In C++, by default, if you write something like int R50, where is it created? It's created on the stack, on the fast memory. So, and then you may say, well, and how do I create things on the heap, right? Because why would you want to create things on the heap, basically?
Is it big array? A huge
Yes. So you want to create huge things on heap. Why? Why not create anything on
Because
stack?
stack is really small.
Stack is really small. It's like 1 megabyte or something like that. So if you create a really big array, you will get our most favorite exception, stack overflow. That's why you want to create objects on heap. There is another reason why you might want to create objects on heap. That's a question to my data structure students who just learned what stack is. Is stack sequential or not?
Yes.
That's a trick question.
It's no, yes or no.
Depending on what?
How you want to access? How you want to access the elements?
In stack, you always access the top element. So stack, is it an abstract or a physical data structure? Abstract. So as an abstract data structure, what it requires to work? Not an array, a physical data structure. An array is one of those. So the idea is that if you implement stacks using arrays, obviously it will be sequential. If you implement it using linked list, it will not. So, but in Java, in C++, all of it is recreated with a stack. So, with an array, sorry. So a stack becomes sequential. And since it's sequential, so for instance, when you will want to create something like a linked list, so you want to create a linked list in your program. Do you know the size? So, do you know the size of the linked list beforehand when you're creating it?
No.
No. If you want to create a vector, do you know the size of vector beforehand?
No.
No, it can increase. But in stack, just like in regular array, you need to allocate a certain amount of memory, and so so all parts of your program knows where they can go and where they cannot. So if you create something like a vector, you cannot create it on a stack like this, because again, you don't know the size. And that means that you need to create it on a heap. But how? Well, vectors, we just create them something like this, right? Vector int or whatever, v. It is created. Where is it created? On the stack or on the heap? Just like we discussed.
Heap.
On the heap, because again, you don't know you don't know the size of the vector beforehand. So you create it on the heap where there is more memory, where it's not sequential, and you can reuse it. Well, okay, but what if I want to create my array? So if imagine my array is 5 million elements. I want to create it on a heap. How can I do this?
New operator.
New operator. So we write something like int r equals new int 1 million. So new operator, it's basically malloc, and delete operator is basically free. there is some subtle difference between malloc and new and free and delete. But long story short, malloc and free is C, new and delete is C++. And so if I have created it like this, what I need to do in the end of the program? Delete array. So let's actually look at the first example. To see that stack is actually faster than heap. So here I have a very easy program, right? So this function creates an array of the size 100,000, and this creates it on the stack. No new operator is happening. And this function uses regular vector, and it creates it on the heap, because as we just discussed, vector by default always uses heap. So that is the difference. So and here I just start start the timer before I add elements to the stack, and here I start timer before I add elements to the heap, right? So it's basically just figure out how much time each of the things will take. So, and now let's run it. Here you go. Almost more than 2 times as fast the stack is. And if I will do this, and we'll do 1 million elements instead of 100,000.
Is there a limit how much you can store on the stack?
A second. Oops.
Okay.
Oops, what happened? Stack overflow, yes. Because 1 million elements cannot fit in my poor old 4 gigabytes of operating memory. Probably. No, it's actually not about the size of my operating memory on my laptop. It's the size that operating system allocated for my program. I can ask operating system to allocate more for my stack. By default, it's not enough. So Nikita, you had a question, right?
Yeah, it was about this.
Yes, so a stack overflow would happen. So that's why even though stack is faster, we want to use new. Well, now the next example is good old linked list, right? We all love linked list, do we? Let me actually sit here probably. Ayana, is it cool? Just to show the example. So this is linked list. I actually do that with templates, scary, but actually that's a very regular linked list. It's double linked list, but that doesn't matter much. So we have our head, we have our node, right? Here you go. That contains data and the pointer to the next. Actually, yes, that's single linked list. So data and pointer to the next, like classical example of linked list. And what happens here is let's just add new node to the linked list. So we create this new node with data that we want to insert to linked list, and then we just add it to the very back. That's all. So just head of linked list and method add that adds elements from and to to the tail, right? So this is my linked list, and this is my program that utilizes it. It's a little bit weird, so we'll see about it. So basically, it's not stopping. It adds 100,000 elements to linked list in a while loop, and then there is a sleep, so I can show you something. So basically, it's constantly adding elements to the linked list. Okay, so let me show you. So I start the program. Cool, it's running. Now I show you this. This is my task manager. Oops. What is going on? Can you guess? See the amount of memory that is being used. What is going on?
Allocating.
I'm allocating the memory, and what I'm not doing?
Yeah.
I'm not freeing the memory. Deletion never happens. So let me stop my program before my operating system stops working because of the lack of memory. So if you look in the linked list, I do new, but I never do delete in any parts of my code. Even because here I have the pointer to my information, and but that pointer is never getting freed. So I allocate memory for my node, but I never delete it. And so all the code that we are writing with the 3 juniors we have here, 4 juniors. 4 juniors, 5 juniors. Yes. Last semester actually was memory leak because we never bothered to write a destructor. And even when we written the destructor, we would say, what a big deal. Just write a destructor, right? I mean, you even have very, very smart compiler that will help you with that. I don't see. Whatever, just write a destructor. But one of the things, remember last time we were discussing copy constructor and move constructor. So the thing is that if you have created destructor, by the rules of C++, all your default copy constructor and move constructor stop working. So that means that if you still want to use move and copy that we discussed last time, and we learned that move is faster and you should implement move to make your code faster, all that logic, it's generated by default by your compiler, unless you create a destructor or one of those constructors yourself. So the idea, so long story short, if you create a destructor, you also need to create move constructor, copy constructor, move assignment, copy assignment. Did we do any of that last time? Of course we did. So the idea is that what's the problem with this? So first, you need to not forget to do delete. And the second is that even if you create destructor that will delete it for you, you will need to write a lot of additional code, not only just destructor. So is it ideal? No. That's why I was not bothering with you all. Because that's spending too much time just to make the class working, just to avoid that memory leak. But this memory leaks good. So you just saw it. So now after you know all of this, I want to show you this bad example. This bad example is bad because it contains mistakes, and I will show it to you in a second. So here we have our structure professor. Professor has a name and teaches some classes. And here we have the structure class. Structure class has a professor, name, and a syllabus. And then there is some main function about it, which we're going to talk in a second. So first of all, why am I saying that professor should be a pointer to a professor instead of just professor? What prevents me from just doing this?
Because we don't need to create a new instance of professor, just like point to some existing one.
Come again?
Just like not to create a new instance of the professor because we already have this struct, and just let me point to this address.
I'm not following, I'm sorry. Yeah, sure.
I think what he's saying is we don't want a clone of the professor, we want the actual professor we have.
I mean, here you go, we can pass by reference, and then we won't create any clone. Why are we need this? Well, see, the thing is that if you see what's going on, there is actually something that's called circular reference. Professor has class inside it, and class has professor inside it. So, and the idea is that if I actually remove this struct class that I added on the top, professor will say, I don't know what class is, because class was never created. But if I will create class on the top, it will say, I don't know what professor is. So that's why what happens is oops, incorrect. I declare class, actually struct class, here on the top. And then struct class on the top, and professor now knows what a class is. But That's first thing. And the second thing is if I leave it like this. So what will happen? So if I, for instance, will write vector int v here, can I use this vector immediately? Yes, because it's immediately initialized with the default constructor, right? Does class professor have default constructor? Oops, it doesn't. That's why I cannot create it because it doesn't have default constructor. So that's why I have to use a pointer. And since I need to use a pointer, what do I mean I need to do? I need to do delete somewhere at the end, but that's okay. That's another show you where you need to use pointers, not just if you use with CRAs. You can say I will never work with CRAs, thus I will never need pointers. But there is another thing. So I have a pointer to a string instead of regular string. Why? Well, there is actually a hint here. Here. Why I'm using a string pointer instead of just string? Can a syllabus contain more than 1 million characters?
Yes.
Theoretically, there is nothing that stops it, right? So yes, 1 million characters is like what? 100 pages, whatever. But still, theoretically, a syllabus. So what? Okay, what if it's not syllabus? What if it's textbook? Can textbook contain more than 1 million elements? Yes. So in that case, if I will put just string, that string will be created on a stack and will cause stack overflow. So again, the idea is that instead of syllabus, it can be a CRA, it can be some file that I want to close after the end of my program, or just a pointer to a really big object that I don't want to be created on stack. So that's why I use new. So now, knowing all of that, here is the main class, and now we have our activity. Activity. Cool, right? So I will try to fit all the code into my screen. Hopefully it will work out. Almost all the code. Unfortunately, it's not scalable. I tested, believe me. So here is the code. So you saw the definitions of professor and class just now. So your thing is, let me see whether I left any. Yeah, so more about that later. Don't worry about this. Any hints here? No, I have. Find two problems with this code. So why this code is bad from the point of view of memory management? Work in groups of 3, I believe. You can work in groups of 2 because there are 3, 2 of you. So let's start now. Yeah, work in groups, please. Don't just look at your phone and work alone. The entire idea is to work in groups. Sure, I said quickly. There's a very simple constructor. I believe it's the default one. So the only notable thing is new here. And for professor, it's super simple.
Oh, it's the class.
Да, вот здесь вот символы сюда пойти.
One problem with this code, I mean, I almost told it explicitly what it is. But there is a second one.
Я понял, я посмотрел. Why are you You can edit through the okay.
Let's have 90 more seconds. Actually, you know what? No, 3 minutes, so we finish at 30 minutes with this activity.
Oh, okay. I see. One program. This one. You see, it is pressed like this. Not no, this you have to. Yeah, you have to. By reference, you should set variable is now. You know now you can do that. Like this. You create this file. It is sequential allocation of memory. When you pass it by reference,
This is going to be a random syllabus. This is the nature because they get added to
One more minute.
So P is our professor. He is a military and We have data structures here. Yeah, we create class, we put the name of the student. So we have 10 classes.
Data structures.
Okay, so what are the two problems? Sure.
So the first problem that we
Okay, so choose one.
discovered is that, for example, when we add some professor, in the future, if this program expands in complexity, it will be difficult to remove all the references of this professor. So, for example, if we want to remove some professor after a long time, we have a lot of records in different data structures where we reference this particular professor. And this, if we delete this professor or even try to delete all the records of this professor, we may make some mistakes because developers make mistakes. And the problem is that there is a very high chance that there will be some reference to this professor after it was deleted. And we will have an address to a point of memory that
Okay, that's actually really close to what the second problem is. So, but what the first problem is? I almost directly said you what it is. It actually kind of not with this code, but with that code.
So,
Sure.
problem that one class reference number and another class reference first, so it's
So,
like circular reasoning.
yeah, so the circle reasoning, but what's the problem with it by itself?
It's never ends.
It's never ends, yes, but what's the problem with that? So what's the first problem with it? No, Eric, I want someone else to answer. So again, I have new here. Do I delete it somewhere?
No.
So if this program's expensive, whatever, there is something after this. So all of that will be existing forever. And then generally the problem is that, like, as it's done currently, it means that I need to, so the user of my class will need to code delete, not me myself, because so the user of my class should know nothing about that syllabus is actually a pointer or something like that, because my destructor should worry about that. But since there is no destructor, there is a memory leak, and we just saw what the problem with memory leaks. But okay, sure, you could say, but that was with this code, not with the code you showed us. What's the problem with the code I showed you? Sure.
So it's bothering me slightly that we allocate a string pointer and then we assign it to a different one, but we only delete the second one.
Okay, so what's that? What's the problem with that? So Valentina says that we create a syllabus, right? And then we say that that syllabus variable is pointing to this. We do that for convenience, right? So as you see, here we do some work with syllabus. Actually, this will be even better. We do some work with syllabus, and so just for convenience, we create another variable, right? So, and then after I delete the C syllabus for data structures, what will happen with this variable syllabus? To what it will point, Gemma?
To the state that's on this.
Yes. So what will happen if after this loop I will do this? Do I need to? Yeah, this.
Error.
It'll give you something random.
Oh, I'm running the incorrect program. Oh no, I need to run this program. Oh, it's eating my operating memory stuff. I need to run this program. And now let's see. Oops. So this is the first print. This one, right? This one is correct. So we added classes, we printed. But the idea is that in this code, we are constantly adding classes that creates memory. But it's at least works. But now here, a very wonderful syllabus, don't you think? So what happened again? I deleted pointer using one, I deleted the data using one pointer, but there is still a second pointer. That's totally fine, that totally could work, and the program has no idea that actually it points to some garbage. So and that problem is called dangling pointer. Yes, I know, very funny. Dangling pointer. So a pointer that points to already destroyed object. And you would say, well, just don't use syllabus. But that brings us back to Eric's idea that programmers make mistakes even if they're ideal. And you say, fine, I will check that pointer actually points to something. I will write if, and then I will write how to check the pointer points to something. So if syllabus not equal to null pointer, then we check. Now let's see. We will run it. Oops. It still worked. Because this pointer, C syllabus. So if I write C syllabus, it yes, C doesn't exist anymore. But I can. Where do I have these classes? It's P classes loss, right? So P classes, P classes size -1, right? So even if I'm somehow, what you don't like, no, you do like it. So this thing is also not equal to null point. So how do we check for it? Yes.
Well, it's not a null pointer because it is pointing to something.
Yes, the memory is garbage now. Yes, exactly. So how do we solve this problem? What if we should write to check for this?
Check if the two pointers are the same.
Okay, it's time for you. Two pointers are the same. It will check the addresses. Addresses are correct. Again, it will not tell you that it points to garbage. So it's time for you guys for me to tell you guys a dark truth about C. There is no way to check for it. You just cannot know whether a pointer points to garbage. The only way to know this is to read through your code and be like, damn, it actually points to garbage. That's the only way. No if or anything will help you with that. So, how do you think, how much C++ developers like this? On a scale of 0 to 10.
-1.
-2?
Yes, something like this. So the idea is that that's why they hated it. And C++ developers actually hate pointers a lot. There is famous saying that good C++ developers should never use row pointers. Never. For no reason whatsoever. But you would say, but Professor Pavel, or however you call me, you just told us that pointers are inevitable. Like, look, this thing is very big. It uses new operator, and new operator returns a pointer. Or, for instance, this professor thing, right? So, what, do we need to write a default constructor so we can use professor without a pointer? Or something like that. Like, you just told us that pointers are necessary, but now you're saying that you should never use pointers. What does it mean? What solutions you have out of this conundrum?
Smart pointers.
Interesting solutions, not obvious ones.
Don't use pointers.
Don't use?
Pointers.
But you cannot. I just said if you want to program in C++, you need to use it. So that means?
Use
Don't put
reference.
big things in your code.
Yes, that's a solution. But if to program in C++, you need to use pointers. What? Don't program in C++. Exactly. That's the solution. But if some evil professor, which is not me, you all know I'm not evil, you saw the song, makes you to program in C++. What's the way? So the way is obviously smart pointers, but why they are smart? Well, the thing is that they actually do all this destruction and figuring out deletion by themselves, but how? So let me introduce you to shared pointer. So it's a feature of C++ 11 or later, shared PTR. So what's shared pointer? So shared pointer is a very easy idea. So when you create a shared pointer, you give it a regular pointer. And so shared pointer does a very simple thing. It counts how many things point to that object that you just created. Let me provide you an example. So imagine you just created this big syllabus. And when you created it, you put it into a shared pointer. So, and shared pointer is now, okay, so one thing, so in this case, this class, so one thing is currently pointing to that syllabus. So if you will look at it, yes, so when I created this data structures class, how many things currently point to the syllabus that is created? Well, only one thing. The object of the class itself has this variable syllabus that is pointing to that object, right? Is this clear, or I need additional operation? So again, when I create an object of class, an object of structure class, call it whatever you want, with data structures as a name, it also creates a syllabus with this line, a very large resource. So currently, how many things points to that string, a very large resource in operating memory? Only one, right? This variable syllabus within object ds, variable syllabus points to that string. Cool. And then when I do this, the idea is that that counter of how many things is pointing to that object is increased by 1. So now the smart pointer knows that there are actually two variables, this syllabus and this syllabus, that are pointing to the same object. Good. And then when I do this delete, or for instance, even easier case, when this syllabus goes out of scope, the destructor of shared pointer is called, and shared pointer is like, okay, let's see. So let me draw you a picture. So imagine again, you have this one string. What's written within the string? Any sentence of English language that is short enough that I can write.
Large.
Sure. I forgot that you're programmers and we have creativity turned off by default. So there's string large, right? And to that we have our first pointer. I will call it first pt because I also like creativity. So good. So again, and so shared pointer, first ptr is pointing to this object. Good. So then what happens? So now the thing knows that I'm the only thing that points to this object large. And then imagine somewhere in another place of the code you create another shared pointer and say that second ptr is equal to first ptr. So now there are two things that point to the same object. And now this thing knows that there are two things. And this thing knows that there are two things. So both of them are aware that another thing exists. So if this thing dies, when can this thing die? When it goes out of scope, when its destructor is called. So you need to understand that shared pointer is a class, right? So it has destructor. And within destructor of that class is written. So if there are other, so decrement the counter of how many things exist, because I do not longer exist, so stop counting me. Decremented by 1. And so after this thing is destroyed by destructor, when it goes out of scope, this thing will be like, oh, I guess there is only one of me now, but that's fine. But then, when this thing also goes out of scope, what happens in the destructor? In the destructor, this thing is like, okay, I was the last one, I'm getting destroyed, now there are 0 of us who points to that object. Why don't I delete this object? So that's the idea of the third paradigm of memory management, at least from the popular one. So the first one is garbage collection. The second one is manual things, like with destructors, right? But it's still somewhat manual. And this one is called reference counting. So it's called reference counting because this shared pointer is just counts how many references, how many pointers, how many arrows, call it whatever you want, is pointing to this object. And when that reference count goes to 0, shared pointer just deletes it. If it's not reaching a 0, it means that it's still used by someone, then there's no need to delete. So do you see how it solves both of these problems? Okay, so maybe an example will help. So let's look at the improved version. So first of all, our professor now has not vector of classes, it's vector of shared pointers to classes. So that means that if several professors teach the same class, the class will never get destroyed before all professors are destroyed. That's the one thing. Do you want to destroy professors? Raise your hand who wants to destroy your professors. Ayana, are you recording? Oh, sorry. Slava, are you recording? Cool. But okay, let's see here. Don't worry about weak pointer for now. So we have our syllabus in shared pointer. So that means that here, when I have created this shared pointer, it's currently having 1 in its reference count. Only one thing is pointing to this string, a very large resource. Good. So then, when I do this, again, don't worry about weak pointers. I create another smart pointer. Let's put it this way. When I create another smart pointer, it's now okay, good. And so when I here delete, so that's the analog of delete that we have now, but now with smart pointer. So when I reset the smart pointer is now not pointing to anything. Everyone knows that. Everyone can check that. By this thing. So syllabus, it's a smart pointer. It can see whether this pointer within, whether the resource within it still exists or whether it got deleted. If it still exists, we can print it. If it doesn't exist, it can tell, well, the thing is no longer exists, sorry, we just deleted it. And that's allowed to solve that problem with dangling pointers. But another thing is that it prevents memory leaks. It prevents memory leaks because, again, as soon as all classes will go to the end of scope, they will call their destructor. Default destructor of class that is automatically generated by the compiler. What default destructor does? It just calls destructor of all the fields. So it will call destructor of professor, of name, and of syllabus. So default destructor of a class will call destructor of syllabus. And destructor of syllabus will be like, I decrease the reference count by 1. And when it reaches 0, I just delete the string a very large resource forever. I wonder whether I can show you the definition of it. Oh, I can. But see, it's very scary. I'm not even sure that I want to show you. I want to find, so this is all constructors, 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 and this is operator equal. I want to find the destructor. Oh, not this. Oh, I think the destructor then is in the class this thing is inherited from. But basically the destructor again, it decreases the reference count, it decreases the amount, the count of things that currently are subtracted. So imagine this situation, that I say, I want to conduct another workshop in 2 weeks. If there is at least one person, and you say, okay, you all say, okay. And then when I declare the one person who will attend, and then when I declare the meeting. I said, hey, I created this new object meeting. If you're interested, please copy its reference to yourself. So please write whatever, fill out the form that Ayana sends you all, right? So, and one person added, another person filled the form, another person filled the form, 20 of you filled the form. And now there are 21 objects, 20 of you plus one of me, who is currently interested in this meeting. And so this meeting will continue as long as what? As long as there is at least one person who thinks that there is a meeting going on. If all of us decide that the meeting is over, what will happen to the meeting? It will get destroyed. We will call destructor of class meeting and whatever. Ayana will pick up all of this stuff. This food will be like collected by kitchenette and so on and so on and so on. So that's how shared pointer works. So when you want something from the object, you take a reference from it, and until at least one reference exists, the object is never destroyed. But as soon as there is zero references, it's destroyed automatically. But then what's weak pointer that you have that you see here? Where I did create it? Here. So weak pointer. It's a smart pointer. They say it for instance that does not take ownership of the object. Another example. So what does it mean? Another example. Imagine that I don't know, art club is having also started their meeting at 4 p.m. Is there anyone who is both here and in art club? Sure, Amalia and Valentina. So for instance, and imagine that Amalia and Valentina go to the head of art club, to Bermeta or whoever, and says, hey, I have this important meeting for me, right? This group session that we are having right now. But in case when it finished, your session is still going, I will come to it. Do you understand this example? So they say to the head of the art club, so I have this another meeting in WARC, but if by the time the meeting in WARC is finished, your art club session is still going, I will come. So that means that if during the meeting of art club, there are like, for instance, 10 people meet, and they decide to finish the session, will they ask Valentina or Amalia? No, because they're in different meetings, they are not there, and the condition was I will come if the meeting is not finished by you guys. So if the guys decide to finish the meeting, Valentina and Amalia will be like, well, and we'll go home or wherever. So that's the idea of weak pointer. So the idea of weak pointer, if you maybe want to read some information or get some information, but you don't want to be like, until I am alive, that thing, that class should exist, you use weak pointer. So for instance, imagine if you're doing logging for big integer. Everyone is like, big integers, the assignment for data structures. Yes, so imagine that you are doing the logging for big integer. You want to take your big integer and write information about it in the log function. But if that big integer gets destroyed, so should that big integer exist while log function works, while it's logging into the, not exactly. So big integer should get destroyed as soon as it feels like it. But if it exists, we will take some whatever metrics from it, write that in logs and so on and so on and so on. So that's the idea about weak pointers. So if we want to read the information, but we want to be like, okay, before these things, but we don't want to be like, this thing should not allow information to get destroyed while it exists. We use weak pointer. So why we use weak pointer here? So look, if you come to think of it, does class own professor? Professor do own classes, right? Because professor conducts those classes. But do classes really own professor? No, classes just know who the professor are, but they have no command over professor. So if you would say, who has command? Class over the professor or professor over the class? I wish. Since professor has over the class, professor has shared pointer to classes. So the classes will not stop existing until professor says so. But if professor gets fired, what will happen to classes? So can professor quit if class is still going on? Well, nobody stops me. I can go like the labor law of Kyrgyz Republic does not prevent me to just now going to HR and saying I'm so fed up with this big integer. I don't want to teach it even one more day of my life. I'm submitting my 2 weeks notice. And then yes, I will stop existing, at least for this university. But will data structure class stop going? No, like the head of the department, Sasha, they will be really angry at me, but they will have to find some replacement for me. So that's why classes have weak pointer to the professor, because they do not extend my work time. So they cannot force me to teach classes that they don't want to. So since they cannot force me, that's weak pointer. It doesn't have enough strength to force me, right? That's why it's weak. So, but on the other hand, can a syllabus exist without a class, a second reader? No, right? So it doesn't make my sense. So while class is going, it should have a syllabus. That's why it's strong shared pointer. Yes, Jane.
So if the weak pointer to the professor is a shared pointer, would that make it impossible to fully delete either one because you have a circular?
No, see that's solves circle reference exactly. Because if this professor will get destroyed, so for instance, I created a professor here. So if I will delete this professor or something like this, obviously I mean, it's not that easy to be, but whatever, if I do this and then, I don't know, this. So the professor will get destroyed here, right? Because this reference will die, and that's the only strong reference that points to the object. So the professor class will get destroyed because all classes have only weak pointers to them, to the professor. If classes had strong pointers to the professor, they will say, I'm very sorry, like I do understand that this professor got fired, but you cannot get fired before you finish the classes. So the classes, if they had strong pointer, they will not allow the professor class to die. So, okay, let me fix it back. So, and the same is here. So this syllabus, it's weak. Why it's weak? Because it's only created as a helpful thing, right? To make work with code easier. So that's why it should not extend the life of the syllabus. So if the syllabus will want to die their own life, on their own, it should allow it to. So on here, we kill the syllabus. We'll say that the object that it points to, this a very large resource, is getting deleted using keyword reset. And so now this, when we want to actually print it, so we can check. So again, because weak pointer does not extend the life of the object, it means that if the object died, if I get fired. So imagine, I don't know, you came to Sasha and you say, I'm a student of data structures. Can you please call professor for data structures? So if Sasha had regular pointer for me, she will try to go to the professor. Professor doesn't exist, AUCA goes off flames and burned up, right? But if she has smart pointer, she can see, let me check whether the professor still exists. And this is what this, because she has weak pointer to me. And this is what this expired thing is supposed to do. It allows you to check whether the object that's the weak pointer, so Sasha cannot stop me from getting fired or from quitting, because she calls weak pointer to me. But she has my Telegram number, she has whatever, she can contact me. But in order to contact me as an AUCA professor, she needs to first check whether I exist at AUCA. And to that, she uses expired. And then, so if I'm not expired, she can lock me. So what does it mean, lock? Lock, it means that temporarily turn weak pointer into strong pointer. So this syllabus will stop being weak pointer and become strong pointer for the duration of this line. After this, it will become a weak pointer again. So that's a long story. So the idea is that since that's again this idea that you cannot just take from the information from the weak pointer directly, and you need to first turn it into the strong pointer and then take the information directly. It again comes to the idea that so if you want to continue the analogy, if Sasha learned that I am the silly professor at AUCA, and she calls me and like, don't you dare to get to quit until the end of this phone call. That's basically why this lock exists. Because imagine if Sasha called me and I was signing the I'm quitting agreement at the same time. So she would think that I still at AUCA, but in the middle of our dialogue I would stop. And that would create a lot of issues. That's why while Sasha is talking to me, she extends my life as a professor. So again, the analog is don't you dare to quit before we end this phone call. So this is what this lock does. And if the syllabus got expired, we just say, well, the syllabus got deleted, sorry, it's too late. So that's long story short about two of the three types of the smart pointers. There's a third one that is unique pointer, but we probably will talk about it when we will talk about patterns of development. So maybe on some future times. So yes, question.
Will weak pointers still point to garbage if you've gotten rid of all the strong pointers?
Yes, yes, they will. That's why you need to check like this. But at least you can check, because if you remember here, there is no way to check whether it points to garbage or not. Any more questions about it? So, before you all go, I know some of you have classes, but like, sucks to be you, I guess. Yes, can you please this and this? Can you again, please, the same questions? Did you like the session? What did you learn? What you want to know more about the topic? I know that I promised X pointers to you, but maybe next time, who knows? And maybe that's just unpaid so you can't. So then don't forget to return those papers and pencils to me. Everyone has pencils? Everyone has pencils? Here you go.